Last week, I talked to you about this idea of an antiderivative. And an antiderivative is exactly what you think it is. It's going backwards. I showed you a couple of formulas. So the first formula I showed you was the big famous one here. It's the power function formula right here. And we really just nailed that one down and did really well. And then we talked about guess and check. I'll just say G and C, guess and check. Some people prefer to use this method called substitution. So you can use guess and check, or you can use substitution. For those that have studied something like this, however, I'm not going to use substitution method in this course because I'm following it the way the book does it. So that's just something to put out there. Anyway, what are we doing today? Well, we're doing the exact same thing as last time, except we're writing it in a more formal way. And here it is. We're going to talk about what's called an indefinite integral. And it's this thing right here. So let's take a look at that and just kind of make sense of what's happening here. So we have this little squiggly line thing, and then we have a dx. Now, many of you are like, what the heck does that mean? And unfortunately, my friends, I'm not going to tell you what that means today. But I will tell you in a very, very detailed way what this means next time, because that's what we're covering next class. It is the main focus. Today, though, I want you to understand the following. Whenever you see this symbol here and the dx here, this is called an integral. And within the integral, inside of that integral, in this box, for example, you put a function. So it could be a function, in this case, of x, because the variable here is dx. So that means that the variable is x here, so as mentioned here. So this function here will be a function of x. So f of x. And all you got to know how to do today is to recognize that whenever you see this, as far as you're concerned, it's an instruction to find the antiderivative of whatever's here and just to give the answer here. So you put the antiderivative right here. I'll just say here anti. And that's it. That's how you fill in the blank here. That's what this is. So as far as you're concerned, whenever you see this symbol with dx today, it's an instruction to find an antiderivative. Sounds reasonable? Shall we do an example? Okay. It's very quiet. Sorry. Thank you, Dogan. I'm counting on you to help me out here. All right. So here is the first example, example 33. So this example here, it says the integral of x squared dx. So what this is saying is, and I'll say it very plain, okay? Very, very simple. It's saying, give me the antiderivative of x squared. That's all it's saying. The integral of x squared dx is an instruction for you to give me the antiderivative of x squared. So, based on our discussion last week, this is pretty easy. Can anybody tell me in the chat, what is the antiderivative of x squared? Oh, that's the derivative, Asim. You got to go the other way. That's squinky line. So, Jai, you don't have to write the symbol. All you have to do is tell me the stuff on the inside there that you wrote. The answer is just this. See, this thing here, you're welcome. No, thank you, you got the right answer. This thing here in red, the stuff that you see in red is an instruction saying, and I'll say it like kind of mean to you, it's saying, give me the antiderivative of this thing. That's what this is saying. So your response to that instruction is to just give the antiderivative. Remember, for those that were here last time, obviously most of us I see here are the same. What you do is you take the exponent and you add 1. Whoops. You take the exponent and you add 1, so you get 3 here, and then you divide by the same number. And if you're like, wait a second, sir, is there a rule for that or something? Yeah, there's a rule right here, and that's what I was highlighting at the beginning of today's class. Let's just grab that for a second. So I'm using this rule here. Nothing fancy, people. That's the rule that I discussed with you in very, very heavy detail last time. So we can use this rule, and we're gonna be practicing the same stuff as last week. So that's why I said to you last time, whatever I show you today is really just reinforcing the skills that you did last time, and that's it. So actually, in a large way, this is very similar to what I'll be quizzing you on today. So let's take a look at the next example, number 34. So in the chat, can someone tell me just in plain English what this is saying? You can say it in a mean way, so to speak, not without the word please or anything. But tell me what this means to you. What should I do? What should I do when I see that? Tell me in that chat. Thank you, Jai. You said it the way I said it. Kind of. Well, but I can't get the tone. I can't catch your tone, but that's okay. Give me. That's it. Give me the antiderivative. So the answer to this is to give me the antiderivative. What is someone else? Thank you, Jai, by the way. Someone else in the chat. What is the antiderivative of x to the 4? Joshua, the rule says that we add 1 to the exponent. Thank you. So we got to add 1 to that exponent. So that's x to the 5 over 5 plus c. Sounds good? Any questions there? You could have that rule in front of you the whole time today. I don't mind copying and pasting it. There's that rule over and over again. First, like half dozen examples are like this. Okay, so I'm going to switch to typing because it's a little bit more clean on my than the drawing here. What's the antiderivative of x to the 7? Anybody in the chat? Oh, nice. X to the 8 over 8 plus c. All right, now someone let me know in the chat, someone in the class there, why the heck do we put this letter C? Can someone remind the class, why do we put the C? Let me type that there. I'll type it over here. Why do we put the C? Why do we need it? Why do we need that constant? Go ahead, Sean.
Yeah, I'll use the mic. I feel like it'll be easier. It's
I
because
love it.
if you find the antiderivative, because that doesn't have a power to it or an x, it wouldn't show up within the antiderivative of that. So you need to make it clear that despite finding x to the 7 in example 35, if there was a constant previously, it wouldn't show up because it doesn't have that extra part to it.
I like your answer. It's very good. To rephrase that.
Yeah, it was very all over the place.
No. I just want to say what you said. It was actually, I understood it clearly. I'm just gonna say it with less in case anybody else was like a little bit overwhelmed. That was great though. When you take the derivative of this, it should get back to what you started, which was x to the 7. And as you know, the derivative of a number that's constant here, c, would be 0. So you can allow for an extra number here. So you got Sean and you got me there. So hopefully that makes more sense. So the derivative of our antiderivative should return us to the original function. Since c is constant, its derivative is 0. Perhaps my answer is even more annoying than my first answer, but I hope that made sense to you. The beautiful thing is that when you first learn this stuff, like little things like that, you might say, oh, I don't really get it. But the point is that you just do it. and then you make sense of it later. I'm not saying I don't want to teach you like that. I'm not trying to do that, but sometimes you learn something, it's a pattern. Like, well, today I'm asking you to just do this, to just look at this integral here and to just do that, to take it on faith from me that you just find the antiderivative because that's what you do. And I'll explain to you why you do that next time. For now, it's just it means find the antiderivative. So there's a little bit of, like, faith that I'm asking of you. All right. What is the antiderivative of 3? What's the antiderivative of 3? Oh, look at that. We got some buyers here. I like that. Yeah, the answer is 3x plus c. Remember that whenever you have a constant, the antiderivative is that constant times x. Think of it this way. You can kind of reverse engineer this. If I said to you, if I highlight this here, and I say, what's the derivative of 3x plus c? That's from last semester, and I think that you would, like, eat that for breakfast last semester. That's nothing. The derivative of 3x is 3, and the derivative of a constant, like pi or 5 or whatever, is 0. So there you go. And whenever you have a number, a constant, the antiderivative is that number times x. Now we're getting into building off of what I just showed you. So what do you do if there's a number in front? Like if you go back to this one, x to the 7, we use that very interesting rule here, which is that you add 1 to the exponent and divide by that same number. But what do you do here? There's a 5 in the front. Now, the way that I would advise you to do this is to not ignore the 5, but I would write this template here. So just treat the 5 temporarily. Treat the 5 like a spectator, like it's not participating. It's just there to, like, sit there and look pretty, kind of like what I do in math class sometimes. All right, so there you go. What you do is you just put the 5 outside like a spectator, and then you do x to the 10 over 10. And of course, one more line of writing would be very nice, because you can make this look a little bit nicer. 5/10 is a half, of course. And I would prefer the second answer. For those that are new to the course here today, there might be a few people in this section, although they might have had me as a professor in the past. The answer, like this thing here, is huge. And this thing here is not a big deal to me. So if this is a quiz or whatever, or an assignment, test, whatever it is, like let's say this question's out of 2, I would give you 2 out of 2 for obviously for this, but I might give you like 1.8 out of 2. I might take off like 0.2. As you saw from your old evaluations, silly stuff like that, I usually take off 0.2. I don't like taking off half a mark, too much, especially when the question's only out of 2. So very punitive. So let's go to the next question here. And you can see that it's kind of like the previous one, except, of course, it's a different power function. We have a 2 in the front, and this time it's x to the 3. So let's see if we can manage that one as well. So here we go. So I'm going to let's play fill in the blanks here, okay? I'm going to put a 2 bracket plus c. What goes in that bracket? Let me know in the chat. What goes in the bracket? Fill in the blank. Thank you, Dogan. There you go. And then I'm just going to write it sideways, a little bit cleaner this way, I guess. 2/4 is, of course, a half. And that's it. That's the answer. Actually, I should write it vertically. By the way, I will post these on Blackboard, as when you're writing your in-class assignment today, I will post all this stuff on Blackboard. So don't sweat that too much. No stress. So let me know in the chat, how do you feel about what I've been showing you so far? Is it coming back to you from last week? So a little bit of a warm-up. I mentioned to you that I'm doing the exact same stuff as last time. I'm just putting this beautiful little decoration here, this squiggly thing, which is called an integral. And yeah, it's pretty much the same. Now, some of you might be asking, What does this indefinite integral stuff mean? Again, for that one, I'm going to actually defer the answer until next time. So I'm deferring two things to you next time. The first thing I'm deferring to next class is what does this, why do we have this symbol here, and why do we have the dx? What's the significance of that? That one I'm going to answer next time. The second thing I'm deferring to next class is the word indefinite. Why am I not talking about that? I want to clarify that next time. It makes more sense in me telling you the story next time. It makes sense, okay? So question 39. Well, question 39 is actually polynomial, and we talked about antiderivatives of polynomial in detail last time. The way that you can treat them is by just finding the antiderivative of each of the terms separately. So this is just, it's more writing, but it's a lot of the same. I'm not going to copy and paste your answer, Jai, but it looks good. So what I'm going to do is, anywhere there is a variable, you see the x to the 3 there, I'm going to put a bracket. And see that 5x? I'm going to put a 5 in a bracket. And then the last thing I'm going to do is the 1. Now the 1, the antiderivative of 1 is 1x. And then you always put a c, because we've always put a constant at the end. So you see how I treat this question. And as you know, you can watch this recording later to set these up again. I always like to just deal with the easy stuff and get it out of the way. And then I make a little template for the higher powers of x. So like x to the 3, x to the 1. Anything that's constant, like a 1, I just immediately just say the antiderivative. I don't bother like making it all a big story and making it all fancy. And you always put a c at the end. So what's the antiderivative of x to the 3? That's what goes here. What's that? So I see it, and then Jai's actually simplified the answer, but can I have the unsimplified first? What goes here in this bracket? Any new people there? Anybody new want to go in the chat? Kind of say hello by writing an answer. Jen-Luc, thank you. Yeah, it's x to the 4. And yeah, it is going to simplify to that. I'm just going to write this step first. I want you to, the people that are kind of like, you know, a little bit worried about this stuff, I want to write down that first step, and then the answer would be simplified to what Jai or Gianluca has in their answer in the chat there. What's the antiderivative of x? What's the antiderivative of x? Just the x only. What goes in this bracket? Thank you, Jai. Thank you, Anthony. Okay, so look at that. We're good to go. Now you might be like, hey, buddy, what are you doing there, professor? Why are you putting the 1 there? Isn't that kind of childish? I don't care. I'll put the 1 there, and if you put a 1 there, I'm good. But because this is not, I know this is not my final answer. I'll put things like that on purpose, kind of as placeholders to help me study, and make sense of where things are going. So final answer, I could copy and paste Jai's answer from a few minutes ago, but I'll just kind of type it anyway here. Whoops, that's an x. So there you go. There's a polynomial. And the next question is the same idea. It's another polynomial. So are you okay with the pace? Let me know. The people that aren't chatting here right now, maybe some of the people that haven't chatted yet, let me know. Is the pace okay? Let me know if that pace is good for you. All right, thank you, people. Okay. Thank you very much. Okay, so let's do this one here. We're going to make a template. So anywhere I see an x, I'm going to put brackets. And remember that 2 is a constant, becomes 2x. And you always put c at the end. In the brackets, don't tell me the final answer. Just tell me what's in the bracket here. Someone tell me in the chat, what goes in this bracket? Very nice, very nice. And over here, Very nice. Now you see how Gianluca wrote his answer. He didn't put the hat thing like Tyler did. You know this thing here. You don't have to put that symbol there. Like if you're writing a quiz or whatever, if you don't put the symbol there, the computer program's gonna say you're wrong. But I'm gonna go over your answers and I'll double check it to make sure it's okay. So for that reason, whenever you do an assignment or a quiz or a test or whatever it is with me, through the computer system, which is the My Lab, what happens is I don't release your mark right away because I'm going to go and look for all that silly stuff that the computer doesn't understand, that I understand and you understand is correct. So for example, if Gianluca was writing the quiz right now, his answer would be perceived as incorrect by the computer, but I would look at it later and I would correct it and make it right. So don't worry when you're writing your assignments or anything like that. If you're like, oh my goodness, I don't know how to type it in a half decent way, and I will understand it. And I'm usually very forgiving with how you type stuff because as a very hardcore computer programmer, I made a lot of silly mistakes typing stuff in my life that have cost me many hours of research time to figure out. So anyway, there you go. So question 41 is now we're diving into some more of this power function stuff. I'm just taking a second to look in the sidebar here. I want to make sure that we're going to get to a good place before the break. So I need to definitely pick up the pace a little bit. So these next ones here, they're ones that we've done last time, but unfortunately they require a little bit of work. So let's go over here and just do that. So the first thing you want to do is rewrite the function in a way that's appropriate with the formula. So you know the formula has to be x to the something. So it would make sense to turn this thing here into x to the something. And then you can find the antiderivative as per usual. So if you add 1, what does the new exponent become? What is this exponent here? Close. Yeah, thank you. You just missed the minus sign, that's all. And then you can clean that up a little bit, of course. So that's going to equal negative 1 over x plus c. So one thing you know about me already is that I want you to present your answer nicely. So I don't want to see a negative denominator and I don't want to see a negative exponent. So you want to touch it up a little bit, make it look like that. So I'm going to go to the next page. You can see the other answer in the sidebar here still. Maybe I can zoom it in a bit more. But we'll just keep on trucking here. So these next two questions are profoundly different, actually. The first one's just like the one we did. It's just x to the negative 3. Sorry, my keyboard is not recognizing the hat symbol. Thank you. All right, so we just add 1 to the exponent. So this time I'm just going to kind of discuss it without questions. So the antiderivative is x to the negative 2 over negative 2 plus c, which equals negative 1 over. Someone confirm. Do they agree with this in the chat? Let me know in that chat. Thank you. 43. 43. Very, very, very critical question. Because it's the rule. Take a look at the rule here. See, in this case, it's 1 over x. And if you rewrite 1 over x, it's the special case. It's the special case. Do you see that? It's the only time. When you have negative 1 here, it's the only time that you write this answer. So for this very, very special question, the answer is going to be ln x plus c. So it's the only time in all of the antiderivatives and integrals that you do anything where the answer is ln in terms of the examples that I'm covering. So why is it ln? It has to do with derivatives. And although we did not cover the derivative of ln in the fall, the derivative of ln x is 1 over x. And the reason there's an absolute value, it has to do with the domain of 1 over x. So the domain of 1 over x, if this ln x did not have an absolute value, the domains would not match, and then there would be a problem. So we're not going to go there, but anyway, you need an absolute value. For 42, if we don't simplify it, Joshua, if you don't simplify 42, you lose 0.2. Whatever the question's out of, you get minus 0.2. That's the deduction. So if the question's out of 3 or 1 or 5 or 10 or 8 or 6, I don't care what the question's out of, you'll lose 0.2. Small deduction, but it's annoying enough to get you pissed off that you want to get it right. Let's say we have a coefficient and add-ons to the thing. Yeah, they don't fall within the absolute value. That's correct. So I'm gonna supplement another question over here underneath. So Ethan's question is this: if I make Ethan, just clarify, is this what you're saying? Like if you have a 5 here? Okay, then yeah, you just put a 5 here. Okay. No, it's a good question, man. Good question. I'm just gonna say here. Let me just clarify here. This is what software am I using? I'm using PowerPoint, Ayo. I'm just writing here a bonus example so people don't think it's like part of the question, okay? Yeah, I'm using PowerPoint, Dale. I have equations and I just kind of type them in. Okay, I gotta move it along, people, because I wanna go at a decent pace for these easier ones. All good. So here we have integral of x to the half dx. So the question is, what is the antiderivative of x to the half? Remember, square root is x to the half. So that would be equal to x to the something over something. And so what goes in the bracket? What goes in the blank? Fill in the blank for me in the chat. What goes in that blank? Thank you very much. You've been doing your homework, people. That's good. Now, fraction in a fraction is a little bit annoying, so I want to see this answer. Although it's not a big deal, I do want to see this answer. I do value this answer more than the original. So let me clean it up. A fraction inside of a fraction is not clean. This is not clean. Doesn't look pretty. So let's move on to examples 45, 46, which are very similar. I have them in the side here. Let me just take this one here and just kind of zoom in the font a bit. As you see, I got the split tab working here with PowerPoint. So you can see the answer here if you need to catch up on that. There's the question. We have a cube root, sorry. We have a cube root. So what we want to do is just add 1 to that. So 1/3 plus 1. So we have here 8x to the something over something. Let me take that 8 out. So 8's like a spectator. If you want, you can put brackets on this. If I follow the same strategy as I did with everybody else, that's how I would set the question up. And over here, it's 4/3. Let the people know in the chat, if anybody wants in the chat, how did I write? Why is it 4/3? Why is that 4/3? Tell your classmates. That's right, Jai. You add 1. So 1/3, when you add 1 to it, you get 4/3. And now it's going to be 8 times 3/4. So 8 times 3/4 is equal to 24 over 4 is 6. So it's 6x to the something plus c. There's the answer. And don't worry about writing this as a root. I don't care if you write it as a cube root or not. For the sake of your time on an evaluation, don't waste your time writing that as a root. Leave it as it is. Okay, let's do the next one. So we have the integral of 8x to the negative a half dx. So in this case, again, it's like the previous one. I don't want you to, examples 45 and 46. 45 and 46, if I were to say, like, are they really similar to each other? Are they different? I would say that 45 and 46 are very, very similar questions. You have a coefficient in front, and then you have a rational exponent here. I don't care if it's a positive or a negative exponent, it's a rational exponent. And you just add 1 to it. Unless it's -1 when it turns it to be, when it becomes ln in that case. So in this case, it'll be 8 with some brackets plus c. And in those brackets, it'll be x to the something over something. That's the template. Even those first examples we did, it looks so similar. So just take negative a half and add 1. What's negative a half plus 1? It's positive a half. And then that simplifies nicely to 16x to the half plus c. So remember, I'm inverting and multiplying. When you do 8 divided by a half, you're doing 8 times 2. I don't care if you write this as a square root. You could write this if you want, if it compels you to. You could write this as 16. You could write it like that if you want. But I'm not gonna bug you about that, because that's all it is, okay? So now we're on to kind of like the triple threat. Look at that, triple threat. What the heck do you do there? Well, as far as you're concerned, those are just 3 exponents, and for each of those exponents, you just add 1. So just add 1 to each of them. So this is equal to x to the something over something plus, whoops. That's all I see. When I see this question, I don't want you to, when you see this question, I don't want you to get scared. I want you to think of it as just 3 of the same things. Oh my goodness, they're fractions. Yeah, they're fractions, but who cares? You got a calculator anyway. If you don't feel like doing that in your head, that's fine. If you don't feel like doing that in your head, I'm not saying do it in your head. I'm not saying to do it by hand either. Grab a calculator, I don't care. Well, do whatever makes you comfortable to get the right answer. It's fine. So I'm just adding 1. Let me know in the chat if I screwed anything up here, because I would be very embarrassed if I were to get anything wrong here. Can someone confirm? Oh, it's too small, Ethan. That's the best I can do. Can you see it now? You're welcome. Yeah, it's probably better if you're having if the numbers are too small in the question. That's going to happen on occasion in this booklet. So it might be better to, if you have a printer, to just print off some of these questions. Anyway, let's clean this up. You got that. You know, I mentioned last time, and I think you'll see it here very clear. Remember last time I used the analogy of a checkerboard? Who remembers me saying the word checkerboard last week? Like how you have an alternating pattern, like a checkerboard, red and black or black and white or whatever the heck it is. Let me know in the chat. Who remembers me using the word checkerboard? Nobody? Okay, anyway, do you see how it looks like a checkerboard? See, it's 4, 5, 5, 4. It's like an alternating pattern. Yeah. Thank you. Whenever you have fractions like this, these types of questions, it always ends up being a checkerboard. So what I'm saying is by using that checkerboard analogy, you can skip this step altogether. This step that I've highlighted, you can actually cut it out. Yeah, if you want to put them together, be my guest, but I wouldn't bother. Don't put them together, Jai, just for the sake of time. But you could put them together if you like. You could also factor out an x out of all of them. But because there's a c here, and this one here is not a common factor, in terms of the denominator, I should say, it's not very fun. For which question? For here, you mean, Barbara? For the 5? Because you take 1/4 plus 1. So specific to your question, just to answer your specific question, each of those exponents, that's what I'm doing there, okay? So it's the pattern with the fractions. It's just thank you, you're very welcome. It's just the pattern with the fractions. It turns out that whenever you're adding 1 to the fraction, all you're doing is adding the bottom to the top, which is why I was doing it so fast. I think you meant to write 9/8 x to, yeah, you're right. You're right. I'm so sorry, Ethan. I got all confused myself. So right here, right? Quality control. A collective intelligence. Yes, the checkerboard. All right. 48. Now, you might look at that and be like, oh my goodness, here we go. This thing just went off the rails quickly, didn't it? But there's beautiful things happening here. Because this question, this here is a monomial. Because it's a monomial, a single term on the bottom, it's a happy face for me. Because you can split it. You can split it into 3 questions. And now you just treat each of the questions separately. So if we clean this up a little bit, we get x plus 2 plus x to the minus 1. And these are 3 separate antiderivatives to be found, each of which is fairly familiar. X is going to become x squared over 2. 2 is a constant. It becomes 2x. And this one here, don't forget that weird one. That's the special one we talked about. What's the red one become? What's here? Thank you, Jai. Yeah, it's ln x. Oh, that's okay. You can do the absolute symbol. On your keyboard, it's under the delete button on the far right. See the delete button on your keyboard? Why do I put the ln? It's a very George, it's a very special case. It's the formula right here, okay? It's this thing here. Because whenever you have x to the negative 1, see x to the n is negative 1, the answer is ln x. The reason that it's ln is because, although we did not cover that in the fall, the derivative of ln x is x to the negative 1. That's why. The derivative of ln x is x to the negative 1. You're welcome, Jai. I want to continue on George's question there, okay? So if you have this, if you have the integral of 1 over x like that, it's equal to the integral of x to the negative 1 dx. Now, if you were to just go on kind of like on faith that you add 1, what's wrong with what's going to happen? Why is this bad? If I try to do it this way, because that's the way that you might be thinking you can do it, just kind of like follow the routine, what's going to happen on the next line? Well, it's even worse than that, Sean. It's even worse than that. Sean's on the right track, but Jai closed the deal on that one there. You see, you divide by 0. Divide by 0. So that's why you don't do that. This is wrong. And I'm not saying that the answer is ln because this doesn't work. I'm saying you don't do that. It doesn't work, period. The answer is ln because the derivative of ln is equal to x to the negative 1. So that's it. 49. We'll take a break soon, everybody. I'm just trying to manage what we're covering today, and I think it would be very good if we did 49 before we take a break, and maybe 50 as well. So that'll put us in a good position for the second half. For those that are new today, the way the class works is you have 2 hours with me approximately, including a break every hour, and then the third hour, if I need extra time to teach you some stuff, I'll do it then. Today I won't. But in the third hour, you have a 25-minute assignment that you do on MyLab. Now, if anybody here is the first time today, and they're like, wait a second, I don't have the MyLab and all that stuff, don't worry. If anybody here is the first time today, and they're like, I don't have MyLab set up to do the assignments, I will deal with you individually, and it won't be a negative way. You're not going to get 0, and it's not punitive. You're not going to get hurt because of that. I'll make an adjustment with your other assignments and tests and all that stuff. So don't worry about that. But the 95% of us here for sure I've seen already on MyLab are set up, so that's not a big deal. So if I can deal with the 4 or 5 people that might have an issue today, so don't worry about it. You can talk to me in the chat during the break, publicly or privately, it doesn't matter. Okay, it's just not a bad thing. I don't want anybody to get worried about that stuff, because the assignments are there to build your mark, not to hurt you. Okay, anyway, this question here is a little bit strange, but I'll kind of give you. Normally, if we were in the physical room, I would kind of walk around the room and see what you're doing with it. But because that's not a possibility right now, I'm going to have to spoil the mystery here. This thing here in the brackets, it actually factors. It actually factors, okay? So that's how you deal with this question. This question, if you're wondering, is on a test. Is this a hard question? Yeah, this question will be a tougher question for sure, because it involves a little bit of like lateral thought. You got to really get your head around what to do here. So now we're finally in a place where we're going to review something we did last time that was a little bit scary for some people. So here's my answer, okay? Here's my answer. We're gonna take some time here on the side to figure out what that answer is. And if you recall, whenever you have brackets of something to a power, I invoke the guess and check method. So I'm gonna do that over here on the side. What did I just do? I thought I just broke PowerPoint. Okay, hang on. I'm gonna guess what the antiderivative is. And the way that I'm going to do that is I'm going to look in the brackets here and see that exponent is 2/3. I'm going to guess that the antiderivative is 2/3 plus 1. So I'm just going to guess that's the antiderivative. And instead of writing 2/3 plus 1, I'm just going to write it as a single fraction. So 2/3 plus 1 is 5/3. I'm guessing the answer. So over here where the answer is, I'm predicting currently, or I'm guessing currently, that the answer is that. And I'm going to put question marks there because I don't know if that's the answer or not, but it's just a guess. But I mentioned to you last time that this guess is probably going to be really good. So let's take a look how good the guess is. The way that we guess, that we confirm the guess is good, is we check by taking the derivative. So what's the derivative of this? Let's go through that process. So the derivative is, it's based on the power of a function. So it's 5/3 x plus 3 to the power of 5/3 minus 1 times something. And that something in the bracket there is the derivative of this. The derivative of x plus 3 is 1. For those that are familiar, I'm doing the power of a function. Also, you can call it the chain rule. If you did the chain rule back in high school, if you took calculus in high school. Anyway, this exponent here is going to become 2/3. So what we're hoping is the following. We're hoping that our guess here will produce the derivative. I should get rid of the 1 here, sorry, because the 1 just disappeared anyway. We're hoping that the derivative here of our antiderivative is this. So my question to you is, are those the same? Let me know in the chat. Are those the same? No. Okay, Sean, are they close? Yes. What's the issue? What's the issue? Yeah, the 5/3. Thank you. So, how do we remedy that? Well, the fix is really easy. And we did lots of these last week, but that doesn't matter. I'll show you more. The fix is right here. You put 3/5 in front. So you adjust the guess. Thank you, Ethan. Let's put some colors here. So we put a 3/5 there. And then that 3/5, it carries all the way down. And because of that, you're preemptively putting a 3/5 there, and then these neutralize each other. So you end up with this is the same as this. So we're successful. So our guess here was not correct, but we adjusted it by putting a 3/5. And that is the antiderivative. So in summary, when you have a brackets to a power, I don't care what's in these brackets, I mentioned last time that whenever you have this circumstance, you always can do the guess and check in this course. However, sometimes it won't work in real life. But for those questions, the skills that I'm teaching you here are not covered yet. See, there are so many techniques for antiderivatives. There are actually courses and courses on them. For example, when I was in university, I must have taken at least 4 courses purely on antiderivatives and related things like that. So I don't want you to think that what I'm teaching you here is all of antiderivatives for the rest of your life. Way, way far away from that, okay? There's lots of antiderivatives. So let's talk about guessing and checking again with question 50. Notice that we have brackets to a power, which is indicative of guess and check. So I'm gonna just put down here. I'll do it like this. So I'm just copying and pasting something to my desktop. So this is what we're trying to do. We're trying to find the integral right here. And we're going to guess the answer. So over here, we're guessing that the antiderivative is going to be to the higher. Oh, shoot. Sorry, Jai. Wrong place. My scroll bar was off. There we go. Better? Okay. I just pasted it to my screen. So we're going to guess and check the solution here because we have a bracket to a power. So what I'm going to do is I'll make my guess first, and then we'll try to see if it's right. We're going to guess the antiderivative right now as being something to the power of 9 plus c. And over here it'll be x cubed minus 3 over 2x squared. If you're getting scared of this guess and check business, I promise you that this is the worst of it. This is the worst of it, okay? Guess and check is the hardest type of technique I'm going to show you in this semester. And if you want to learn more of them, you can definitely explore other courses on it outside of what I teach here at the college, though. I guess autocorrect isn't working today. Anyway, we're guessing the antiderivative, and we're going to take the derivative of our antiderivative and see if it matches the original integral, the function in the integral here, or what we call the integrand. So let's take the derivative of this. So if you want to take the derivative of something in brackets to a power, you bring that power down, and then it becomes to 1 less. So 9 minus 1 is going to be 8. And then you multiply by whatever's in the brackets. You take the derivative of that. So in the brackets, we have x cubed, whose derivative is 3x squared. And we have this thing here, whose derivative is going to be, if you bring the 2 down, it'll be 3x. So minus 3x. Now, when we look at the original question, it kind of looks okay. See, this it looks very similar to what we have here. Now, you might be like, how is that so? Well, take a look. Okay, the thing in the brackets to the power of 8, it matches. And that always matches because we deliberately made it 1 power higher. So now the issue is that we have a 9 here, and we have some 3's here that we have to deal with. So what I'm going to do is, in this bracket here, I'm going to factor out a 3. So I want you to factor out a 3 from that. So I'm going to also shuffle the terms around a little bit. So I'm going to take this guy over here, and I'm going to put it here for aesthetic reasons, so it matches how it looks in the original question. So you see how that kind of looks more similar to what our target is. Our target is this. Then I'm going to pull this 3 out as a common factor and bring it outside. So now it's over here. But then you multiply that times 9. So you get 27. So there's the little story. And you can see that it's putting us in a place where we can get to what we want, which is to have it match. So finally, we've made our guess and we've taken the derivative. Our hope is that this thing here should look the same as this thing here, or even here if you want. So in the chat, are these the same? Yes or no? Are they the same? No. But are they close? Okay, what's the issue, Jai? What do we need to do? What should I put here? Yes, I need to put something there preemptively so that I can get rid of that fraction. That's 27, sorry. So I'm going to put 1 over 27 here preemptively to deal with it. And that 1 over 27 is going to filter all the way down this page, just like that. And because of that, the 1 over 27 is going to neutralize this 27, giving us exactly what we want, which is this. the antiderivative. And that's the answer to the question. So this guess and check business, I know it's scary and I know it's annoying for people because it is a process. But I mentioned to you at the beginning of class, there are two ways at least, there's many ways, but there's at least two ways that are very, very common, which I'm just showing you here. One way is guess and check, and then the other way that I've slashed out here is something called substitution. So you could use a method called substitution to do that question. Although I'm not teaching you the method of substitution here for reasons that I did not teach you the chain rule in the fall in the limited time that we had. So thankfully, questions 51, 52, and 53 are very, very short. So it's kind of like, you know, when you go to the gym, I don't know if people work out here or whatever, I'm sure some people do. When you go to the gym, it's interval training, right? You do something really difficult, and then you do something really easy. And then you do something difficult, and you do something, you kind of balance it out. So that's kind of what I'm doing here. I'm interval training your brain. So the previous question was tough. But then this question is a little bit nicer, and the next one's nicer, and then again, you're going to get a tough one. So you see, we're just kind of bouncing back and forth between difficulties here, because I don't want to hammer you with 10 questions in a row that are hard. I perceive the previous question as a hard question. Anyway, in this case, let's rewrite the integral a little bit nicer as x squared plus x to the negative 1 plus 3. And now you can tell me in the chat, what's the antiderivative of each of those things? So something plus something plus something plus c. What's the first question mark equal to? Thank you. Jai. Okay, can I have another volunteer in the chat? What's this one here? This one's the tricky one. What's the antiderivative of that? Oh, Brian. And finally, we have the 3. What's the antiderivative of 3? Thank you, Ravindra. Very nice. So there you go. We have what we need. We're good to go. Let's go to 52, people. I need to pick up the pace a little bit on these easier ones. These are similar to what we did before the break, so they're not intended to be like some intense learning here. It's just a review of what I covered with you in the first half. Sorry about that. Just dropped something. Okay, so here we have 3x to the something. And that something there is funny. It's a cube root squared. So it's 2/3, but it's upside down. It's a reciprocal, so it's a negative 2/3. So that's not this is not a difficult integral because of anything other than the exponent being weird. So I'll do this one with extra care because I know people are kind of insecure with their fractions possibly. So I'm just preparing my answer a little bit here. So I'm gonna do here, I'll do this, okay? Negative 2/3 plus 1, and then negative 2/3 plus 1 again. And then this becomes x to the 1/3 over 1/3. And finally, we have 9x to the 1/3 plus c. And there you have it, my friends. Look at that. Another answer. I don't care if you write this as a cube root. Feel free to do so, but I'm not going to ask you too much about that. Okay. Our pace and our target for what I want to cover today is on point, my friends. So let's go to the next one. This one here, 53, is very similar to 48 because we have a monomial on the bottom. Let me see if I can recycle this. Oh, that was a bad idea. I'm going to recycle that, right? Let's see if it works. Okay, maybe not a good idea. Anyway, the idea here is that you could split it into two integrals, into two terms. You could write it as x over plus like that, and then here you have, that's a minus sign, sorry. You have, whoops. So you have the following, and you can see that it actually cleans up really, really nice. See this thing here? What does that become? In the chat, let me know. Thank you, Jai. And this one here, what does this become? You can use fraction exponents if you want here. X to the half. It's x to the half. Because if you look at those two things there, it's 1 minus a half. If you subtract the exponents, it's 1 minus a half, which is a half. So then you have your answer, which is to raise the exponent by 1. So that's x to the 3 halves over 3 halves. And the antiderivative of 1 is 1x plus c. So you could write this a little bit nicer, which I'll just continue it over here and write 2/3 x to the 3 halves, etc. I'll just put it there. Anyway, maybe I shouldn't write the 1 there. So I'm going to talk to you a little bit about, we're going to use notation that's a little bit different. It's actually more like we did in the fall. In questions 54, 55, and 56, we're going to do something that's a little bit more primitive in terms of the notation. But it's going to be something that I think that you'll understand hopefully without too much stress. It's question 54 here. I'll just say it like this, okay? And there are lots of these to practice in your textbook. It's reconstructing a function from its derivative. So as far as you're concerned, this question is more on the line of an application question. Now, I'm not telling you a word problem here. I'm not giving you like, f prime is the rate of change of something in manufacturing or construction. I'm just saying that it's a rate of change of something, and given the rate of change, could you go back and reconstruct what the original function is? It's actually mathematically not a difficult question to do. I promise you this question is not hard to do. It's just we're not using the integral notation here because, frankly, you don't need to use that notation to do this type of question. So this question in reality could have been like a thinking question on your final test last semester, because you need to kind of go backwards and find the antiderivative. And if it was on your test last semester, it would have been like the last question, like the really, really tricky one. The one that everybody hangs out after class and says, "How did you do that, sir?" Anyway, okay, so what we're going to do is we start off with the derivative, which is 8x. And we go back to the original function by just finding the antiderivative. So what is the antiderivative of 8x? Okay, let me know in the chat. In other words, you do this. What goes in the blank? Oh, beautiful. Beautiful, Jai. Yeah. You take the antiderivative, as we've been doing all day so far, and you get, we just write on a separate line here, you get 4x squared plus c. So as far as you're concerned, do you kind of see how it's exactly what I've been doing with you the past hour and a half? Just finding the antiderivative. So the question though is, how is this question different? How is this question different than the previous ones? And the answer is right here. I'm telling you some extra information. I'm telling you that f of 1 equals 3. So by using that information, I can actually calculate the final value, what c is. So since we know f of 1 equals 3, we can find the value of c. I use the word particular here. You could use the word specific, but in the mathematical term, we use particular because it's called a particular solution. So in other words, this thing here, because the value of c can be anything, that's called a family of solutions. And then over here, we're going to find the particular solution, the specific value of c that matches the given information. So what you're going to do is you're going to plug in 1 comma 3 into this function to get c. So you get 3 equals 4 1 squared plus c. I plugged in 3 for y and 1 for x. So c equals -1. So the final answer, whoops. So the final answer is equal to 4x squared minus 1. So that's the process for reconstructing a function from its derivative. So we're going to do that a couple more times in the remaining questions 56 and 55. And then we're going to do an application question, a real life question. And then you'll have a break, and then you can do your quiz after. And after we finish these 3 questions, I will be available in this chat for anybody that's having any concerns about MyLab setup and all that technical stuff. And I appreciate if some of the students stick around here that remember the process for MyLab to assist with that, because my registration to MyLab is different than a student registration, so I might not give you the exact correct process. This is stuff that we would, for 95% of us here, this is stuff that we dealt with in September, and it was not a big deal. But I don't want anybody new today to be like, oh crap, I don't know what's going on with this software stuff. So I'll be here to support you for that. With that, sorry. Okay, let's reconstruct another one here. So it's kind of the same thing. You're given a derivative, and then you're given some particular information about the original function, and your whole objective here is to go and reconstruct the original function. So that's what we're doing again for the remaining examples, is reconstructing. So I'll write the word reconstruct, because it's another one of those. So in this case, we're given the derivative is 6x squared. So the original function is equal to 6 times something plus c. So I'm doing what we did before. I'm putting my bracket here, and in this bracket, I'm going to put the antiderivative of x squared. So what goes in that bracket? Anybody else? Anybody who hasn't spoken in a while there? Who wants to throw in a antiderivative for the class? So again, thank you. Yeah, that's x to the 3 over 3. And we can clean that up, of course, because that needs a little bit of love and care, a little bit of TLC, little TLC there. That's 2x cubed. There you go. So that's the family of solutions. It's a milestone, but it's not the final answer. So now we're going to go and take that further and actually do something useful with it. So we know that 2 comma 5 is a point on f of x. So let's plug in 2 comma 5 to get c. A little bit of keyboard lag there. So if we put 2 comma 5 and we get 5 equals 2 cubed plus c. So I got -11. Can someone confirm -11 in the chat? Thank you. Thank you, thank you. It's amazing, you know, people have websites, they have search engines, they have derivative calculators, they have all this crazy, crazy technology. But you know what I have? I have 34 people in the chat that are pretty smart. And I have a guy whose name's Brian that I confuse it with the word brain. So Brian's twice as smart. No offense to everybody else. I'm just joking. Brian, are you there? Where are you, Brian? I was making jokes. There you are. Okay, good, good. So I haven't offended anybody today, so I'm in a good place. I don't like to offend people. I just like to make fun of myself sometimes anyway, lighten up the mood a bit. How do you feel about this reconstruct? Let me know in the chat. What do you think about this reconstruct? Oh, you're very kind. Thank you. Thank you, Gianluca. I got the thumbs up there. I got the props today. Easy peasy. I'll give you a fist bump, but hang on. Hang on, Doyan. I'm going to give you a real fist bump. I'm going to just crack open that video. I'm giving a fist bump to you. There you go. Boom. All right. Okay. So anyway, let's play around with a couple more of these. The only difference in the next one is that it's a square root. So like, don't get too rattled about that. It's just more practice of the same. Okay. So I'm just going to say the word reconstruct as a trigger. Reconstruct. Dot dot dot. And you know the game that we're playing. So f of x, well, f prime actually, let's rewrite the derivative differently. I'll write it as 2x to the negative a half. So then we get f of x is equal to negative a half plus 1 is positive a half. That's positive a half. So that equals 4. Now you're going to be like, hey, buddy, what did you do there? Why'd you write a root? Why are you being weird, Professor Gatsis? Why are you being weird, buddy? The reason I put it as a root, and the only reason I put it as a root, is because I got to put numbers in there. Thank you, Ethan. The reason I put it as a root, so this is x to the half. This x to the half here, I rewrote it. Let me color it up for you. I rewrote that as root x. And the reason I did that is because I got to plug in numbers. Whenever I want to plug in numbers, I'm going to go to the radical form because it's easier. So use 9, 8 to find c. We have 8 equals 4 square root of 9 plus c. And then that's 8 equals 4 times 3 is 12. Someone confirm c is negative 4, please. Gracias. Thank you, my friends. I know there's someone in the chat saying, I'm not your friend. I'm just joking. I'm just joking. That would be me on a very miserable day. If it was like snowing outside and you're already basically stuck in your house anyway, if you're non-essential, I mean. So I'd be kind of like, oh my God, I don't want to be friends today. I just want to do this math and move on with my life. Anyway, I don't feel like that. I love snow. Don't get me wrong. If I had my way, people, if I wasn't teaching today, if like, you know, like you're on holidays or something like that, I'd be up in Algonquin going on a beautiful hike right now. I love going to Algonquin Park. Okay, let's put all our fantasies aside here and do one more question. And you can see, look, it's a practical question. There's words. There's dollars. When I see words and I see dollars, I think, oh my goodness, it's real life. It's a real life question. Oh my God, who would have thought? Okay, so anyway, all jokes aside here, we're going to do a real practical question here. And I'm just going to walk you through what's going on here. So we're given the following. The analysis of a company's records shows that the rate of change, that's a derivative, of the profit, P, by producing X generators is given by this. Now, I know there's people here that are like, wait a second, what the heck does this mean? Okay, so don't worry, I'll write it over here. This is what it means, people. It's the same thing as saying P prime of X, okay? So it's just the derivative as far as you're concerned. We're just finding the derivative. Sorry, we're given the derivative. Let me correct myself there. We're given the derivative. So it says that find the profit function. So find P of X. So we're just trying to find the antiderivative of this. And then it gives you some information here. So let's talk about how this works. Let's write this in like more plain language. The question is saying find P of X. Given that, okay, now the thing says here, if you do not produce any generators, so this thing about a loss of 5,000, that's saying that if the profit for producing 0 generators is negative 5,000. There, I've turned the question into something more benign, something more boring, like the previous question. See? You're given a derivative and some side condition, which is that there's a certain point on the graph. Now it's the same question. You're given the derivative, and you're asked to go back and reconstruct the original function, given some information about that original function, which in this case, that it passes through the point 0, 5,000. Write that down here, okay? Passes through the point 0, negative 5,000. So that's what we're working with. That's what we're working with, and now we're going to go and proceed and do that. So let's start by just writing down this profit equation, a derivative, I should say. And I'm going to rewrite the actual original derivative there in a little bit more, a nicer way to actually build the antiderivative. So we're going to have here 600, 30 minus x. So I'm just copying the question a little bit differently. I'm going to write that to the negative a half. That's 60x minus x squared. So just to be clear, the original question, this thing here is the same thing as this. Okay, all the yellow stuff is the same. I'm just writing it more pleasant. Okay, a little bit more easy to do our work shortly. So now we need to actually reconstruct the original function. So to do that, we're going to guess, because it's guess and check. So we're going to guess that P of X is equal to this. Whoops. That's what we're going to guess. We're going to take the thing here in the bracket, which is what we've been doing with guess and check all along, and we're going to add 1 to the exponent. So if you take negative a half and you add 1, then you get positive a half. So that's my guess. This is what I'm perceiving. I'll highlight this in a second. This is what I think the original function is. And I'll put it in purple, and I'll make it bold, and that's what we're trying to do. So let's see if we can, let's take the derivative of this and see if our guess is perfect, or at least if it's in the right area code. So if we do the derivative, we got this. So this is 60x minus x squared. And then we have here negative a half. And then you take the derivative of what's inside. So you take the derivative of this stuff, and you get 60 minus 2x. At this point, it's a little bit important to clean it up a little bit. So I'll just do that. I'll bring this guy here to the middle, like that. And then I'm gonna do this. I'm gonna take this 1/2. All right, it's hard for me to highlight the right thing. I want to take 60 minus 2x and multiply it by 1/2. And that will give me 30 minus x, leaving us with this. Okay? So let's make a comparison here. Let's make a comparison here. This thing here should look like this. Because if we find the antiderivative and then we differentiate that antiderivative, we should end up with what we started. Do we end up with what we started with here? Are these the same? Let me know in that chat. Are they the same? They're close. Thank you, Amir. Yeah, they're not, but they're close. So what should I put here to make it perfect? What should I put here so that these match? What number do I need to put here? Yeah, that's right, Jai. You put a 600 there. You put a 600 there. So if we put a 600 here, then this 600 is just going to trickle down the page like a waterfall. You see that? Just all the way down. And then this is multiplied. Make sure that we put a multiplication here. And now they're the same. Now they're the same. I'll do it in red here. This is the same as this. And I'll say yes. Amazing. So this is the answer. Whoops. This is the antiderivative, which represents the original function. We can highlight that. Maybe that doesn't look very good. Anyway, that's the answer to the question. But now we're going to actually get a particular value for that. So let's finish the question over here. So we now know. So we know that the profit function looks like this. I'll take an extra line of writing here, and I'll rewrite this as a square root. You don't have to do this, but the reason I'm doing it is it looks a little bit nicer when I plug numbers in. That's all. So let's use 0, negative 5,000. Find C. So plug in 0, negative 5,000. So we have negative 5,000 equals 600. And then you get here 60 times 0 minus 0 squared plus C. That's negative 5,000 equals 0 plus C. So C equals negative 5,000. So the final answer is going to be this. Like that. So there you go. Are there any questions? Thank you, Sean. Do you see now? Do you see how what we did today is very similar to what we did last time? Although there was a little bit of like notation that you had to get used to, the integral symbol, for example. But I hope that you see, based on what we did last time, today's lesson in terms of the fundamental mathematical skills, even the harder stuff like guess and check, was the same as last week. I wasn't teaching you something new this week in terms of the nuts and bolts, the mechanics of it, because the techniques of finding antiderivatives, that underlie whatever we were doing last week are the same that we did this week. So I want to emphasize that with you. I'm doing antiderivatives and integrals with you for 4 weeks. And across those 4 weeks, the same skills that I'm doing in the first week carry over into the second week and the third week and the fourth week. So you're going to get a lot of the same thing over and over again. So really, really take that to heart, that what we're doing here is really a very compact and repetitive process. Because as you know, many of the mathematical skills that you have to learn in life, and at least in your experience thus far, were a combination of repetition and ingenuity. And what you're seeing more of today with me is repetition rather than ingenuity. Last week was more of an ingenious discussion because we were thinking about why the guess and check method is the way it is, why it works, or why the antiderivative you add 1 to the exponent for a power function. So anyway, it's 9:50. I will gladly end the class now. I'll stick around in the chat. So let me just wish you a lovely week if you're going to take off at this point.